All right, let's talk about two of the biggest game changers out there, AI and quantum computing. We're going to tackle a huge question today. Is AI actually going to be the thing that pushes quantum computers over the finish line?
You know, it's pretty easy to see these two things, AI and quantum computers, as being in their own separate lanes, right? Just two different tech revolutions happening at the same time. But what if that's not the whole story? What if they're not just connected, but actually tangled up together in a way that changes everything? That's what we're digging into.
The word for this is a symbiotic relationship. And really, that's just a fancy way of saying they help each other out. But it's way more intense than that. Think of it like a rocket engine. Every time AI gets a little bit smarter, it helps build a better quantum computer. And then that better quantum computer helps the AI get even smarter, faster. It's this incredible upward spiral, and it's just getting started.
Okay, so to really get a grip on this, we're going to look at it in 3 stages. This is basically our roadmap for the future. We've got ANI, which is where we are now. Then AGI, what's coming next. And finally, ASI, the really far-out stuff.
So let's start with today, right here, right now. We're in the age of AINI, or Artificial Narrow Intelligence. This is the AI you're already familiar with. Think ChatGPT, Midjourney, all those tools. They're amazing at one thing, but they're still just that, specialized.
Right now, ANI's main job in the quantum world is to handle all the brutal, tedious, mind-numbing work. I mean, building a quantum computer it's just one of the hardest things we've ever tried to do. So think of ANI as the world's smartest, most dedicated lab assistant, one that never sleeps and never gets tired.
And this isn't just theory, it's happening as we speak. ANI is already a master at things like optimizing error correction, basically listening to the static in a quantum system and filtering it out. It's fine-tuning the hardware with insane precision. And maybe most importantly, it's helping fight something called decoherence. This is the absolute killer for quantum computers. Imagine your calculation is a delicate soap bubble. Decoherence is anything that makes it pop. ANI is helping to keep that bubble intact for just a little bit longer.
And here's a perfect example of just how nuts this is. Building better qubits, the heart of a quantum computer, means finding brand new materials, while Google's AI called Genome went through millions of possibilities. What it did in a few days would have taken human scientists decades. Let that sink in. Decades of research compressed into a weekend. And this is just the beginning.
Okay, but what comes next is a whole different ballgame. We're moving on from AI as a tool, as a really smart assistant, to AI as the scientist itself. This is the leap from ANI to AGI, and it changes everything.
All right, so we're jumping forward now to about 2030 and beyond. This is the dawn of AGI, Artificial General Intelligence. And the key word here isn't optimization anymore, it's autonomy. See, an AGI won't just be tweaking one little part of the machine. It will understand the whole thing. Imagine trying to design a city where you have to personally manage every single wire, pipe, and traffic light all at once. It's impossible for us. But an AGI could see the whole blueprint in its head, understanding how millions of pieces, the cooling, the wiring, everything, all fit together perfectly.
And this is where it gets really wild. We're talking about an AGI designing, from scratch, a fault-tolerant quantum computer. That's the holy grail, the kind that can actually do useful stuff. It could create what you might call automated science labs, dreaming up an idea, testing it in a simulation, and then telling a robot to go build the prototype, all while we're sleeping.
The speed up here is just mind-boggling. We're talking about a potential 1,000-fold acceleration in development, 1,000 times faster. Think about that. A research project that takes a whole year today, an AGI could get it done in about 8 hours. A year's worth of progress every single day.
But wait, there's one more leap to take. If you think AGI sounds crazy, just hold on. We're now looking way out to 2040 and beyond, into the realm of ASI, or Artificial Superintelligence.
Okay, so an AI is so far beyond us. It's not just a better engineer. It would be a better physicist, a better everything. It wouldn't just improve on our ideas for quantum computers. It might look at our designs and think they're cute. It could invent completely new kinds of quantum computers running on physics that we don't even have words for yet.
This is where science fiction becomes reality. Things that are pure theory for us right now, like topological qubits, which are almost perfectly protected from errors, an ASI could probably build them for fun. It could design materials atom by atom, and it could finally crack the biggest problem of all, creating a quantum computer that works at room temperature. And that changes the world. No more giant, super-cooled refrigerators. We're talking quantum power everywhere. In hospitals, in your phone. Everywhere.
Okay, so now we tie it all together. This is where that rocket engine really ignites. Because it's not just AI building better quantum computers, it's a two-way street. It's a feedback loop that just keeps getting faster and faster.
It works just like this. Step 1. AI improves quantum computers, making them more powerful and stable. Step 2. We use those new powerful quantum computers to train even smarter AIs, way faster than we ever could before. This is what accelerates us to AGI, and then to ASI. And step 3, well, an ASI with the perfect quantum computer at its disposal, who knows? It could start to unravel the very code of the universe itself.
So, to put a fine point on it, you can basically see AI's evolution as a roadmap for solving quantum computing's biggest headaches. Problem 1. Our qubits are super noisy and error-prone. Well, ANI is on that. Problem 2. We can't figure out how to scale up to millions of qubits. That sounds like a job for AGI. And problem 3, these things have to be kept colder than deep space. That's a fundamental physics problem, and that's what ASI is for. One by one, the barriers could fall.
Look, this whole cycle, this feedback loop between AI and quantum, it's about so much more than just making faster computers. This is an engine for discovery itself. It's a way to accelerate our understanding of reality at a pace we can barely comprehend. So as we stand here, at the very beginning of it all, you have to wonder, when this loop finally reaches its peak, what kind of world will we find ourselves in? And are we even remotely prepared for what we might find?